Hello dear students, many students were confused in this JEE Advanced question. So let us take a look at this question. Let us first analyze the question. A small block of mass moves on a frictionless surface of an inclined plane as shown in the figure. So the small block is moving on this inclined plane. The angle of the incline suddenly changes from 60 degrees to 30 degrees at point B. So at this point, the angle of incline is changing from 60 to 30 degrees. The block is initially at rest at A. Assume the collisions between the block and the incline are totally inelastic. So from here this block is released and we need to assume any collisions that the block makes with the inclined plane are completely inelastic. Okay. So this is a paragraph question and there are 3 questions under this paragraph. Let us move on to the first one. The speed of the block at B immediately after it strikes the second incline. Okay. So this length, if this is 60 degrees and this is root 3 meters, this will be 3 meters. Okay. This is 3 meters. So when the block comes from here to here at point B, its velocity will be root 2 GH. So I can just directly mark this as under root 2G into H. Okay, that is equal to root 60 meters per second. Okay, this velocity is before it hits the second incline. Now, when it hits the second incline, an impulse acts on the block in this direction. See, what is the force acting on the block due to this incline? It is the normal reaction force. So, which means the impulse is due to the normal reaction force. So, impulse is acting in this direction. If impulse acts in this direction, it can change the velocity in this direction only and not perpendicular to it. So what we'll do is we'll resolve the velocity into 2 components, one along the impulse direction and the other perpendicular to the impulse direction. The one perpendicular to the impulse direction remains untouched. It is not going to change. Okay. So if this is root 60, if I take the components, this is 30 degrees and this is 60 degrees. Okay. So 30 degrees and 60 degrees. So this angle will be 30 degrees. So if this is 30, then this component of velocity will be root 60 cos 30. Okay. And this component will be root 60 sin 30. Now, anyways, he's saying that the collision is completely inelastic. If the collision is completely inelastic, then the velocity of separation by velocity of approach, E becomes 0. So this E will be equal to 0 in a completely inelastic collision. So that means the velocity of separation is 0. What happens is this velocity vanishes. Okay. After collision, this velocity vanishes and we have this velocity only. Okay. So after collision, before collision root 60, after collision root 60 cos 30, that will be root 60 into root 3 by 2. Okay. So this will be root 45 meters per second. So this will be the correct option. Okay. Next, let us move on to the next part of the question. The speed of the block at point C immediately before it leaves the second incline. So we have calculated after it collides here, what was the velocity? Okay. Now what is asking is, what is the velocity when it comes here? So if this is if this is 3 root 3 and this is 30 degrees, this length, this will be again 3 meters. This length will again be 3 meters. So here it was root 45. Here it was root 45. And so at C, what will be the speed? Directly we can write the speed at this point, Vc square equal to Vb square, that is 45 plus 2 into G into H. Okay, so that will be 45 plus 60. So Vc, I'll directly write Vc is equal to root 105 meters per second. Okay, and so we have again B option, which is root 105 meters per second. Now, what some students had done was, in the first question, they did not take a collision here. Okay, if you do not take a collision here, what is the speed of the block that you get here? You'll get root 60 meters per second, right? So in the previous question, let us say you had not taken a collision, you got root 60 meters per second. So what will be the velocity at the C? Vc square equal to Vb square, that is 60 plus 60. So Vc comes out to be under root 120 meters per second. Okay, and if you had done the wrong method, you would have got the first question wrong, you would have got even the second question wrong. Okay, so this question was based on how you did the first question. It might seem easy, Vc square equal to Vb square plus 2gh might seem easy, but if you had done the first one wrong, this you would have got wrong. So let us say someone had done the first question correct, he would have got 4 plus 4, that is 8 marks. If someone had done the first one wrong, minus 1, minus 2 marks. So just by spotting it, the difference between the marks of the person who had done correct and wrong is 10 marks. Okay, so that is why this is not an easy question, this is a tough question. Okay, so this is the second part. Let us move on to the last part of this question. Let us come to the next part. If collision between the block and the incline is completely elastic, then the vertical component of velocity of block at point B immediately after it strikes the second incline. See, in the first question he said here the impact is completely inelastic. Now he is saying that it is elastic. Okay, so the block is coming here, here it is elastic. I just want you to think why the block will go like that. The last time it just went like this. Okay, and now you see the diagram why it is going like that. We'll calculate and find out and see what is the whatever he asked, the upward component of velocity. We'll calculate that and see. Okay, again the same diagram, just that now our coefficient of restitution is 1 in this one. Okay, so as usual, when it before striking B, what is its speed? Its speed is root 60 meters per second. So I'll just write that here. This is root 60 meters per second, and we have seen that this angle is also 30 degrees. This will be root 60 sine 30, root 60 cos 30 this one, and root 60 sine 30. And this root 60 cos 30 was equal to under root 45. So I'll just write under root 45 this one directly. Okay, and this one will be root 60 sine 30, so that will be root 60 by 2, so meters per second. Okay, so these are the two components. Now if the collision is elastic, then E equals to 1. That means velocity of separation should be equal to velocity of approach. So the approach along this normal is root 15, so the separation velocity also must be the same. So finally, the velocity of the block will be what? Tell me. This remains unchanged, root 45, and this velocity becomes root 15 meters per second. Okay. So finally, the block's velocity is root 45 and root 15. Now, what is he asking? He's asking the vertical upward component of the velocity. Okay. So what is the vertical upward component? Let us just write down this. Okay. So if this angle is 30 degrees here, okay, so this angle also will be 30 degrees. Okay, and this angle, this is 30, this also is 30 degrees. So the vertical component of velocity will be root, so vertical component equal to root 15 cos 30 minus this is another component, root 45 sin 30. Okay, so what is this? Tell me. This is root 15 root 3 by 2 minus root 45 by 2. So that is root 45 by 2 minus 45 by 2, which is equal to 0. Okay, so this is the correct option. So after collision, if the vertical component of velocity is 0, which means the only velocity is the horizontal velocity of this block. Okay, I want you to again, let us go back to the diagram again and see, okay, how the velocity is. You see, so this will bounce like this after colliding. In the inelastic one, it just went like this, and here it bounced and went. Why this question is very good is that in many books we just see that there is an incline and there is ground like this, and they ask us what is the speed of the block when it reaches the bottom of incline, and we directly say it is we do half mv square equal to mgh, and directly we say it is root 2 gh. But the velocity of this block after it comes down depends on what collision the block has with the incline, and that is a concept that was tested in this JEE question. Okay, so beautiful question, and I hope you all like the visuals. Okay, this is very important, like seeing and able to imagine what exactly is happening rather than just writing the mathematical equations. Okay, so see you all in the next video.